Howdy, this video covers graphing transformations, so pretty much just transformations again, okay? So let's go ahead and do 1, 2, 6, 7, 10, and 12. Okay, so for number 1, we have 2f of x. Well, actually, for the entire first page, we're going to be using the polynomial even parent function. So f of x equals x squared, or I guess more likely the quadratic parent function, okay? And we're going to be using our transformation here to transform that function, okay? So we have a 2f of x. So we have a graph, and we're transforming our quadratic parent function. So let's go ahead and just plot our parent function first. Okay, so 0, 0, 1, 1, 2, 4. Now, sorry. Now we have our parent function, and we have this 2 on the outside of our function notation, meaning we're multiplying our function notation by a number larger than 1. Meaning if we had our notes out, we would know that this means we're going to stretch this function. Okay? If we multiply by a number less than 1, it's compressing. But since it's larger than 1, it's 2, we're going to stretch our function by a factor of 2. Meaning we're going to multiply our y values by 2. So this is 1, 1. Our y value is 1, so 1 times 2 is 2. So our new point will be right here. And then 2, 4. Our y value is 4. So we're going to multiply our y value by 2, which is 8. So 4 times 2 is 8. Same for the other side. 2 and then 8. So our new graph is right here. So there is your transformation. Now the translation for your function, we're given 2f of x, and we need to write down what our actual quadratic function will be. Okay. So here we have f of x equals x squared. There's nothing around f of x, and there's nothing around x squared. But here we have a 2 on the left side, outside the function, outside f of x. So then we're going to put a 2 on the left side, outside x squared. So 2f of x equals 2x squared. Now for number 2, we have negative f of x. We've seen this before. So if we have our parent function points, 1, 1, 2, 4, then we should know that the negative on the outside means it's going to reflect over the x-axis. So our point 1, 1 is 1 above the x-axis, so it'll reflect to 1 below the x-axis. 2, 4 is 4 above the x-axis, so it'll reflect to 4 below the x-axis. And there is your graph right there. Okay? So our translation, we have negative f of x equals, all we do is put a negative on the outside of our x squared. So negative x squared. Number 6. Number 6, we have negative f of x plus 3. So first, again, let's put our parent function points. 0, 0, 1, 1, 2, 4. 0, 0, 1, 1, 2, 4. Okay. Now, this negative here, again, is going to reflect it. Now we have a positive 3 on the inside, which hopefully we should know by now. Positive 3 on the inside means left 3. So we're going to flip our function downwards across the x-axis, and then move our function 3 units left. So 0, 0 is going to stay on 0, 0, but it's going to move 3 points left. 0, 0 doesn't flip. And then 1, 1 will flip downwards and then move left 3. 2, 4 will flip downwards and move left 3. Same for the other points. And our new function is right here. Our new graph is right here. Okay. Now we're given, for our translation, negative f of x plus 3. We have a negative on the left side of our f, so we're going to put a negative on the left side of our x squared. Now on the inside, we have x plus 3. So on the inside of your parentheses, put x plus 3. And then since we're dealing with x squared, on the outside, we're always going to have a square outside of parentheses. Okay? And that's it. Okay, number 7. For 7 and 8, all we're doing is describing the translation. So here we have a positive 5 on the inside, which means left 5, and then minus 7 on the outside, which means down 7. So we're going to say translates left 3 units, and down 7 units. Okay, that's it. Number 8, don't freak out. I'm not going to help you, but this negative, you should know what negative means. You should know what this means. You should know what this means. But we also have a 2 here, which is larger than 1. Something less than 1 is going to be compressing. A number larger than 1 is going to be stretching. So you're going to flip, stretch by 2, write 1, up 3. Okay, I won't write it down for you, but hopefully you can, pause and rewind and stuff and listen to it again. Number 10. Describe the transformation of the following equation in a complete sentence. So before we were transforming our parent function. Now we're transforming an already transformed function. So our equation 1 is f of x equals x minus 5 squared plus 2. Equation 2 is f of x equals x minus 4 squared plus 2. So the difference is minus 5 minus 4. What's the difference? So negative 5 plus what equals negative 4? That's going to be a plus 1. So plus 1 on the inside, what does that mean? A plus 1 on the inside, you should hopefully know, means left. So we're going to say translated 1 unit left. Okay? So from function 1 to function 2, it went left 1 unit. I can show you visually as well. 3, 4, 5. So here's our x-axis with up to 5 because of our 5 there. So we know that our function went right 5. So right here. Now this function, the minus 4, is at 4 to the right. So right here. Now the difference between function 1 and function 2 is function 2 is 1 unit to the left. And that's what we put, translated 1 unit left. Okay? Number 12. Last one. Rewrite the equation f of x equals negative x minus 2 squared plus 3 if it is reflected across the x-axis. Okay, so yeah, rewrite this equation. If it is reflected across the x-axis, translated 2 units left and 3 units down. So let's go ahead and rewrite it. F of x equals negative x minus 2 squared plus 3. Reflected across the x-axis means you put a negative on the outside of your function. So right here. All right. Translated 2 units left is a plus 2 on the inside. And then 3 units down is minus 3 on the outside. So what happens with this function? So a negative and a negative cancel. A minus 2 and a positive 2 cancel. Positive 3 and a negative 3 cancel. And you're left with f of x equals x squared. How about that? All right, and that's it. Go ahead and finish this up. Remember, everything's due on Mondays. Thanks for watching.